Hello, welcome again. We are covering the subject fluid mechanics for various gate exam. Next topic in the chapter of properties of fluid is vapor pressure and cavitation. So here, first of all, defining vaporization, a change of state from liquid to gases is known as vaporization. So this evaporation, which depends upon temperature and pressure, occur because of continuous escaping of molecules through the free liquid phase. Suppose we have liquid inside a vessel at atmospheric pressure, then there is continuous escaping of liquid from this free surface, and this will convert into gases and develop a pressure on the free surface of the liquid, which is called vapor pressure. Okay. So now at this pressure the liquid vaporizes. Okay, so that's why it is called vaporization. Now, reading out this, consider a liquid, say water, which is confined in a closed vessel. Let the temperature of the liquid is 20 degrees Celsius. The pressure is atmospheric. This liquid will vaporize at 100 degrees Celsius. When the evaporation takes place, the molecules escape from the free surface of the liquid. These molecules get accumulated in space between the free liquid surface and top of the vessel. Here, these accumulated vapors exert a pressure on the liquid surface. This pressure is known as vapor pressure of liquid, or this pressure at which the liquid is converted into the vapor. So now, suppose we take this case again, and the temperature is 20 degrees Celsius and pressure is atmospheric. So now if we reduce the pressure, then the evaporation can also take place. Okay. And if we reduce the pressure, the boiling temperature will reduce, because 100 degrees Celsius boiling temperature is corresponding to 1 atmospheric pressure. As we go on reducing the pressure, the evaporation temperature or boiling temperature is also changes. Okay. So if this pressure is reduced to such an extent that the water will boil at 20 degrees Celsius, then this pressure will be a vapor pressure or less than vapor pressure. Okay. So now reading out this, again consider same liquid at 20 degrees Celsius at atmospheric pressure in a closed vessel. If the pressure above the liquid surface is reduced by some means, the boiling temperature will also reduce. If the pressure is reduced to such an extent that it becomes equal to or less than vapor pressure, the boiling of liquid will start. Though the temperature of the liquid is 20 degrees Celsius, thus the liquid may boil even at ordinary temperature. If the pressure above the liquid surface is reduced so as to be equal or less than the vapor pressure of liquid at that temperature. Okay. So now consider the case of flowing water. When water is flowing in the machine, there may be the region of very small pressure, and there may be a region of very high pressure region. So here, suppose this is your small pressure region, and here the water will vaporize at the temperature at which it is flowing, and bubbles will form. So these bubbles, when are flowing with the water, so when these bubbles will reach at the high pressure region, suppose region 2, they have the tendency to collapse. Okay. And when these bubble collapse, then high pressure water will enter into it and cause a cavity in the material. So this is called cavitation. Okay. So this is called cavitation. So bubble form in low pressure region and then travel to high pressure region, and then these are collapsing. So these are the so these are the this is the phenomenon in flowing water of phenomenon of cavitation. Now reading out this. Now consider a flowing liquid in a system. If the pressure at any point in this flowing liquid becomes equal to or less than the vapor pressure, evaporation of liquid starts. Yes. The bubble of these vapors are caused by the flowing liquid into the region of high pressure where they collapse, giving rise to high impact pressure. The pressure developed by collapsing bubble is so high that material from the adjoining boundaries get eroded and cavities are formed on them. These phenomena is, this phenomena is known as cavitation. So this is your cavitation. So this is vapor pressure and cavitation, and this is the closing of chapter properties of fluid.